So in the last video, we expanded more on the topic of the binomial theorem and on the idea of using the numbers in Pascal's triangle as coefficients within the binomial theorem itself. So now we will just continue on the same idea of the binomial theorem by first simplifying this expression, which is a plus b all squared. So if we simplify this expression, we will get a squared plus ab plus b squared. And then yet again, if we simplify the expression a plus b all to the fourth, we'll get a to the fourth plus a to the third b plus a squared b squared plus a to the b, which is to the power 3, and then plus b to the fourth. And then, so this comes to this conclusion. This then leads up to this conclusion, which is the binomial theorem comes in the form of a plus b to the power n, and then where n is even, the number of terms produced will always be odd. As you can see, a plus b, where n is 2, which is an even number, you're going to get how many terms? 3 terms. And then from there, a plus b is to the power 4, so n is 4, which is again another even number. The number of terms is again odd. So how many terms are produced here? We have 5 terms being produced. And then the middle term will always have a and b being powered by the identical half of n. So this then is shown in this, I like to normally show it in this way. So where n is even, this will be such that a plus b is to the power n will be equal to a is to the power n plus all these terms in between. And then when we get to the middle term, this is what we'll have. We'll have a powered by half of n, and then we will have b powered by another half of n plus all these other terms in between plus b is to the power n. Now let us take a look at, for an example, in these numbers or in these expressions that we solved previously. A plus b is to the power 2. It's equal to a to the power 2 plus a times b, which is ab, plus b is to the power 2. So now, if you notice this, you will see that there are 3 terms being produced. So the middle term is ab. Now, if you look at the powers of ab, or the numbers that a and b are being raised by, it is such that they are raised by the half of 2. Now we know that 2 is our number n. So the half of 2 is 1. So we know that a is now being raised by 1. B is also being raised by 1. And then let's look at a plus b is to the power 4. We'll get a to the power 4 plus a to the third b plus a squared b squared plus a times b to the third plus b to the fourth. So we know that within this expression, we have 5 terms being produced, and the middle term is a squared b squared. So now, since the middle term is a squared b squared, we can see that 2 is the half of 4. So 4 is actually our number n yet again. So this then shows that this proves this idea here, which is the idea that the middle term will always be powered by the half of n, and b is also going to be powered by the half of n, which is, it then sums up to this idea that within the middle term, you'll find that a and b will always be powered by the identical half of n. And so let us then prove this other idea that I also mentioned, within the last video that the binomial theorem follows a pattern